All right, okay, so still about multiplying identities. We have the example 1. Find the values of sine 2 theta and cos 2 theta when sine theta is 3/5. So let us get the value of this and the value of this when sine theta is equal to that. Okay, good. Maybe okay, maybe you can recall these ones here. You can recall some of these formulas here. That a sine 2 theta is equal to a 2 cos theta sine theta. You must recall those ones. Then also, a cos of 2 theta is equal to a cos squared theta minus the sine squared theta. We shall be using them. Okay. Now they want us to find sine theta and that. So let's start with sine 2 theta. Starting with sine 2 theta is equal to, because they want us to find this and that. So I'm beginning with this. Now let's expand this using the identities. So it will be 2 cos theta sine theta, like that. The order doesn't matter. Here it can start with the sine theta cos theta, or like this, no problem. Okay, now you realize that now we have a sine theta. Sine theta is known, it is here. But do we have cos theta? No. So to get cos theta, we shall now say here like this. We are picking from the fact that sine theta is equal to a 3/5 of 2 pi. We are taking from the fact that sine theta is equal to 3/5, whereby this one is opposite. This is adjacent, that's hypotenuse. So this is a 5. Now shall we get this other counterpart? That is 5 squared minus 9. 5 squared minus 9, and that is, I think, 7. 5 squared minus 9. Please, I'm getting this other counterpart. You all know how to go about that. You can put the letter x, then you go via Pythagoras theorem. Personally, I will save time and we just go direct. So 5 squared minus 3 squared. That will be, oh, that is 16, by the way. 16 and the square root of 16 will give us a 4. So therefore, let's read off cos theta. Cos theta from this will now give us adjacent a 4 over hypotenuse, which is a 5. Now let's come and substitute. Come and say now, sine 2 theta is now equal to 2 cos, but cos is 4/5. Okay, times 4/5. Also times a sine is a 3/5. So what will be that answer finally? All right, this is over 1. 8. 8 times 3, that is 24. So the answer will be 24/25. That's the value of sine 2 theta. So sine 2 theta is equal to that. Successfully done. Let's now come to this. They are talking about cos 2 theta. Okay, they want us to get cos 2 theta, but now cos 2 theta is equal to what? Let's use this very identities here. Cos squared theta minus a sine squared theta. We have it here. This will now be substitute. A cos theta is 4/5 minus a sine theta is a 3/5. And now this will be 16/25 minus a 9/25. What will be the final answer? That will be 7/25. So 16 minus 9. That is 7/25. So cos 2 theta is equal to that. As simple as that. Let's now go to number 2. Number 2, then I was saying example 2, eliminate theta from the following equations. Eliminate theta from the following equations. Then what you have to eliminate is x is equal to cos theta and y is equal to cos 2 theta. Alright, you start with this magic. It is done which tells you what to do next. You start with one which has this 2. Compare, you have this and this. The one with the 2, with the double angle, with the multiple angle is what we deal with. So start with this. So shall say, from our y is equal to cos 2 theta. Our y is equal to cos 2 theta. So now we shall say that, okay, our y is the same as, let's put the identity for this. Our identity is cos squared theta minus sine squared theta. That is the identity we're having. So this is y is equal to, now let's substitute for this. Now this will be cos squared theta minus, or maybe from the identities, okay, let's just go direct. This will be 1 minus, this is the same as 1 minus a cos squared theta. This I'm getting from sin squared plus cos squared is equal to 1. When you make sin squared a subject, you get this. I've substituted, so the value of y will be 2 cos squared theta minus 1. Or if not that, we have this identity somewhere proved for you. You can go back in the videos and refer. Okay, so here we shall say y is equal to, put a 2 cos squared theta minus 1. So y will be now the same as a2, but what is a cos theta? Cos theta is same as x. So it will be now x but squared minus 1. So now your y will be the same as a2x squared minus 1. With this, you will have eliminated theta y. In the final answer, you don't have anything like theta. So with that, you have eliminated the theta. Okay, good. Next, we have x is equal to sin squared theta, sin squared 2 theta, comma y is equal to cos 2 theta. I told you, pay attention to these ones with the 2. So we shall now say solution. Solution, we shall now say, where should we begin from? Where can we begin from? Where can we begin from? Okay. With this, we can say that from x is equal to, now this one is same as just sin 2 theta, everything going to be squared. You can see that. That's the method I'm opting to use, but there are very many methods. So with this, shall have the 2 cos theta sin theta. That's what you're having, but of course, don't forget our square. And when that square is there, I shall get here 4 cos squared theta sin squared theta. That's what you're having. Okay. The 2 works on each and every guy inside there. That's why the 2 became a 4. 2 squared gives us a 4. Now we want to substitute. But our cos is y. So therefore, we'll come and say that, okay, it has been our x. So our x is equal to a 4. Now I want to remain with only cos. So I'll say 4 cos squared theta in bracket. Put the meaning of this. The meaning of that from sin squared plus cos squared is equal to 1 will give us 1 minus a cos squared theta. That's what you're having. Then after reaching that level, you can now say if x is equal to a 4 cos squared theta in the bracket 1 minus cos squared theta, then let's put what is cos theta? Cos theta is y. So where is cos theta? I put y. So x is equal to 4 into y but squared into 1 minus a y squared. You can now expand. So x will be equal to, okay, this time that will be a 4y squared minus 4y squared times y squared will give us 4y power 4. And there you will have eliminated the theta. Still, an examiner can set in this format, can say if x is equal to this and y is equal to this, show that x is equal to 4y squared minus 4y power 4. When you say that you have theta but the final answer doesn't have theta, it means that they will be calling you to eliminate. Don't forget to subscribe. All right. All right, still let us proceed with the more examples about multiple identities. These identities are very important. Sin 2 is equal to that, cos 2. Now cos 2 can be this, or can be that. You choose any you want, but this is a bit simpler to use. So memorize these ones here, just cram them. Okay, good. We have solved the following equations for values of theta 0 to 360. We want to solve this. Now what we do? Shall now say solution. Now, your attention must be on a point where we have these 2. For Pythagoras, we were looking at the point with the power 2, a squared. We were paying attention there. For this, we pay attention to where we have a 2, 4 onwards. A double angle. Double angle means if you have theta, it can be 3 theta, can be 2 theta, can be 4 theta, can be 8 theta. Whenever you see that, just know we are in for double angle Z. All right, good. Then let's look at this. So we shall have a solution. So sin 2 theta is equal to a sin theta. Now what does it mean? Bring the meaning of this guy. The meaning of this guy is here. With this, you come and put that in the place of that. So it will be now 2 sin theta, a cos theta is equal to a sine of theta. We have that. Now, please, in trigonometry, we don't divide like here. If you divide and you find that the trig function you're using to divide has disappeared, just count yourself wrong. What you do here, you must not divide, but instead collect like terms, because here when you divide by sine, sine will disappear totally. When you see that kind of case, then you must collect like terms, and that will be a 2 sine theta cos theta minus a sine theta is equal to what? To 0. And I told you that a trig function and a 0, you have to factorize. Common factor is sine theta. Brackets shall remain with cos theta minus 1 equals to 0. Then from there, you come beside and say, you can say, let's start with either sine theta equals to 0 or cos theta minus 1 also equals to 0. Now let's handle both cases so we can get the answers. This will now be, okay, here get theta is equal to sine inverse of 0. And now theta will just be 0 degrees. Okay, now we're not going to the quadrants because 0 doesn't have anything to do with the positive or negative. I'll leave it as that. So come to this. Find that cos theta is equal to 1, collecting like terms. So theta will be equal to a cos inverse of 1. And now theta is equal to cos inverse of 1 is 0. Do it on a calculator, but calculator must be in degrees. Right, so now theta will be now equal to, now from the quadrants, my quadrants are here. Okay, from the quadrants, I have here theta, 180 minus theta, 180 plus theta, 360 minus theta. So, y is equal to positive there and there. So, what are we going to take? We're going to take theta itself, which is 0, comma, this one, 360 minus 0 will just remain a 3 and 60. So, you come and say that therefore, conclusively, our answer will be general for this and this combined 0. Now don't put 2 zeros because they are less the same, comma a 3 and 60. Those are the answers for this. We are applying in the double angle identity Z. Okay, let's now move to this other part. We have cos theta plus 1 equals to 0. It's one way we want to deal with it. Okay, your attention must be here, 1 with the 2, a double angle. So you choose, but your selection must be in relation to which other trig function do you have there. I have this 2, but the one I bring must be similar to this, must have a cos theta in it. So I can look for the formula of this, but one which has this. Let's go there. You say that we have cos theta equal this, cos theta equal this, but this one has sine, this one has cos. So I will take this one because I have a cos there. So I'll take this. So now we say in the solution, I'll say now cos 2 theta plus cos theta plus 1 equals to 0. In the place of this, I'll put this guy. So it will be now 2 cos squared theta minus 1, right, plus cos theta plus 1 is equal to 0. Like we are, the 1 has gone away. So it shall remain with the 2 cos squared theta plus a cos of theta is equal to 0. We're a bit lucky. It was going to yield the quadratic equation, but we're lucky. Trig function and the 0, factorize. So factorizing will be cos theta bracket 2 cos theta plus 1 is equal to a 0. There like that. Now we're going to either or. So either cos theta is equal to 0. That's what I'm having. Or a 2 cos theta plus 1 equals to 0. Let's solve either way and have those answers. Right, so here we have theta is equal to a cos inverse of 0. By the way, what's the cos inverse of 0? Don't always rush to say that is a 0. Don't always rush. Is the calculator to tell you. So cos inverse of 0 is 90. So theta is equal to 90 degrees. But since it was a 0, it doesn't have a sign. I'll leave it as that. come this side, this will be, okay, 2 cos theta will be equal to negative 1. I've got the like terms. So it will be that cos theta will be equal to negative half. There like that. So theta will be equal to a cos inverse of a half. I told you the reason why we do this. I explained in the first videos, you can look for them. I explained why we don't put a negative here. Because this negative only shows the quadrant where cos is a negative. So theta will be equal to cos inverse of a half is 60 degrees. And from our circles here we are theta 180 minus theta 180 plus theta 360 minus theta. So it means that you shall say theta is equal to, all right, where do we have cos as a negative? It is this quadrant and this quadrant. From all student teachers cry. All cos is positive here and here. These are the negatives. So which answers we're going to take? 180. The first thing is 180 minus theta, but this is your theta. So 180 minus 60 will be a 120, comma. 180 plus 60 will be a 240. Like that. Then you can come and say that therefore my answers will be, start with 90, comma, 120, comma, a 240. Simple as that.